Yeah, this is the thing. In fact, operational research is a very important element. Many people call that in a different names. Even universities in abroad, they call it in a different names or something like that. So earlier it was called like decision science or management science, as the name suggests, as DS and MS. But still, in some universities abroad, they still follow management science and decision science. And then they talked about operational research. So this is where before World War II they talked about not operational research but operational research, and some people have also referred at operational analysis also. So depending upon the nomenclature, they had their own ideology on this particular thing. So it's basically a group of mathematical concepts or mathematical optimization techniques, or even a mathematical decision making entity that's all combined together, and the entire uh, chunk of all this potpourri of all this methodology we called operational research. So that's what basically it means. So that's currently we call them as operational research universally. And some people also refer this as mathematical programming. So that is pretty much close to an operational research, but then like that has got its own variation and something like that. So we'll discuss that during linear programming and other sorts of thing. And operations research and management and operations management, do not confuse operations research with operations management. That's partially, both can go together, but operations management is entirely different. So that's why I just wanted to emphasize it's not an operational research. But anyway, this is not part of an engineering curriculum because this is more of an MBA stuff. But all we look into is operational research. And then in a nascent form, OR is a short form of operational research. It is generally called as an optimization. It's called an optimization, or sometimes people call this as a numerical optimization. And for mechanical engineering, it is also called as industrial optimization, like scheduling jobs to machine. It's more of an industry perspective, like scheduling personals for a job, or scheduling service time, or computing the ideal time of a machine. All those things are approximately close to an industrial sector. So some people also they refer as industrial optimization. But anyway, everything put together is more of an operations research. And sometimes if you take up an management degree, they call the same concepts in a different terminology called quantitative analysis. So do not get carried away by a different terminology called quantitative analysis or quantitative techniques, but it's just the same. It's just the replica of OR or operations research, right? But systems analysis, people talked about systems engineering during industrial revolution. They formulated a specific process and how an industry should be, and they refer this to be systems analysis or systems engineering. So operational research has this nascent form in this paradigm called systems analysis. In fact, even in civil engineering, we had a course called systems analysis in engineering design. So that's basically an operational research for civil engineering, but that course gets dropped. But now they offer OR to them also. So that's how it is almost. And for computer science, there's something called information theory. Like they talked about decision tree, and all this machine learning algorithms they develop now has its origin in information theory. And information theory is a part of an operational research. So it means that operational research has almost many field that that enhances so many other fields, and also encompasses different genre or different disciplines also. So that's a very, very important thing you should know about operational research. And some people they call this resource management techniques also. This is also approximately closer to an MBA kind of stuff, or a management course, which is called resource management. How do you optimally use your resources? And that's also part of OR. So basically OR is an entirely different stuffs, or it encompasses various decision making methodologies, and it also can be called it in a different way. So that's what basically means. One thing I wanted to emphasize is that the word research, this is what many students have asked me, like the research, are we going to do something related to a research, or it is all about a study on how to perform research, or how to do or carry out some literature review or making a methodology for research. And this is absolutely no. It's all about a mathematical decision making methods will be using to problem solving, or basically an analogy to aid decision making. So that's what basically an operational research is all about. So this is a quick overview of what is operational research. So even if you have any discrepancies in your mind, like what is this course all about, it's all about a mathematical program, I mean mathematical problem solving using different methodologies, something like that, right? So this is basically the overview of operational research diagram format. So OR stands for operational research. So what are the different things or different components that are associated or that influence the OR is what we can discuss in this particular thing, right? So three prime areas. One is called mathematics and scientific computing, another is science, engineering and technology, and third one is very important called soft science, in which we'll bring in the psychology, we'll bring in the management and all other different aspects, right? So OR is the integration of all these three different fields, the mathematics, the science, engineering and technology, and psychology and management. This is probably many people call them a STEM: science, technology, engineering and mathematics. But mathematics being a science, so I put it at science, engineering and technology. And sometimes mathematics and science, this is the portion of it. Say for example, the Markov analysis. So we'll be discussing about Markovian chain and all in the course of time, but those are the concepts that are integration of mathematics and science. So that's how it is, like something. Sometimes mathematics and management, say for example a network analysis, that's probably in module number 4 or 3. We'll be looking into the different ways in which you can navigate from one place to another, and we'll find which is the shortest route of traveling, or basically a famous problem called traveling salesman problem, by which will optimize his route so that he has a lesser time in travel, so as the cost of the transportation gets minimum. So those concepts are an application of mathematics as well as a management. So that's also this area. And management and science, engineering and technology, like construction of building. So scheduling for a building, so building is purely a technology or an engineering perspective. And then how do we schedule that, like in terms of the days, and those kind of knowledge, we'll put it in this particular integration, management and all the science, engineering, technology. And in fact OR is a combination of all these things. So it's just a broad field. It's just a combination of all these things. And earlier, before the popularity of the personal computers, or the computing facilities, and this is only there called mathematics, but now people called us scientific computing, right? So in those days, many calculations were carried out by manual dexterity or by manual method, but the problems, the complexity of the problem increases, the manual working on that problem will be very difficult, so they prefer computers. Earlier they used to write huge codes and they have to do a lot of things in computers to get the results. But now, due to advancements in computing facilities, say Python has got very straightforward code in practice, and they can make use of that to do a very big complex task using uh, the programming in no time, or something like that. So that's why scientific computing also plays a huge role in this arena of operational research. So this is a holistic overview of OR. Probably in the next lecture we'll be focusing about the historical importance, or the chronological order of development of OR methodology. But basically this Venn diagram will tells you what is OR is all about. So this is a comprehensive overview which talks about OR in a greater sense, right?